Alright, so today we're going to be learning about similar figures. We're going to learn to determine whether figures are similar, and then how to use scale factors, and how we can also find missing dimensions in similar figures. When we're talking about similar figures, we're talking about figures that have the same shape, but not necessarily the same size. Two triangles are similar if the ratio of the lengths of corresponding sides are equivalent and the corresponding angles have equal measures. Angles that have equal measures are called congruent angles. So let's look at what this means. So corresponding angles means the same angles in the same location. So for example here, we have the 90-degree angle, so angle C is corresponding to angle G because both of those are 90 degrees. Here, angle A corresponds to angle E because they're both 43, and angle B and angle F are corresponding. So A and E are equal, B and F, C and G. Now, what that means is when we look at the sides, we can find corresponding sides. So since A and C connect the 43 and the 90, that corresponds to E and G. Okay, and you want to make sure that you're writing them in the same way. And then this little sign down here means similar. So we need to determine which rectangles are similar. Now since they're all rectangles, we know that all the angles are right angles, so the angles are congruent. So now we're going to look at the sides. So we're going to compare length and width. So I'm going to try with J to K first. So here I'm going to put 10, which is J, over the 5, which is K, and that has to be the same as the 4, which is J, over the 2, which is K. So 10 divided by 5 is 2 over 1, 4 divided by 2 is 2 over 1. So we can say that J is similar to K. Now what if we compared J to L? So we have 10 to 12 has to be the same as 4 to 5. So when we look here, 10 to 12 can reduce, they're each divisible, which would be 5 6. Well, 5 6 is not equal to 4/5. So J and L are not similar figures. And you could do K to L as well. You could do 5 to 12 has to be the same as 2 to 5. Since I can't reduce either one of those, these are also not equal or similar. So now it's your turn. I want you to pause the video and try to figure out which two rectangles are similar. So here, if we do A to B first, we have 8 to 6 has to be the same as 4 to 3. If we divide 8 and 6 each by 2, these are the same, so we can say that A is similar to B. If we look at B and C, we have 6 to 5 has to be the same as 3 to 2, since we can't reduce the 6 to 5. These are not similar. And then lastly, we have 8 to 5 has to be the same as 4 to 2, and once again, these are not. So in the end, we just have rectangle A is similar to rectangle B. Now when we're forming these ratios and proportions, the ratio formed by the corresponding sides is what determines what's called the scale factor. So first we're going to look at how we can use scale factors to find missing dimensions. So if we have a picture that's 10 inches tall and 14 inches wide, we want it to be scaled to 1.5 inches tall. We want to figure out how wide the picture should be for the two pictures to be similar. So since they give us how tall it is, we're going to compare to how tall it is in the original picture. So I'm going to take the change picture, which is 1.5 inches, and compare it to what it originally was, which is the 10 inches. I'm actually going to divide that. So if I do 1.5 divided by 10, I actually get 0.15. This number right here is our scale factor. Now what we're going to do is use that scale factor and multiply it by the width that we know, which is 14 inches. So I'm going to use 0.15. I'm going to multiply by 14, which gives us 2. And so this is going to be 2 inches, and that's telling us how wide the new picture should be. Actually, it's not 2 inches, it should be 2.1 inches when you multiply that out. So now it's your turn. Why don't you go ahead and try this problem on your own? Okay, so here we have a toy replica of a tree, which is 9 inches tall, and the length of the tree branches of a 6-foot tall tree has a branch that's 60 inches long. So, when we compare, the replica is 9 inches. Now the problem here is the 6 feet is not in the same dimension, so we have to change our inches to feet. So I'm going to do 6 times 12, which gives us 72. So the 72 is actually what's going to go in the denominator. If I do 9 divided by 72, I'm going to get 0.125. Now that I have my scale factor, I'm going to take it and multiply it by my other dimension, which is the 60 inches. And once you do that, you're going to get an answer of 7.5 inches. So that's how long the tree branch should be in the replica. Now one thing that can help you is actually drawing diagrams so that you can see how the figures relate to one another to determine if they're similar. So now we can also use equivalent ratios to find a missing dimension or proportions. Okay, so t-shirt design includes an isosceles triangle with side lengths of 4.5, 4.5, and 6. The advertisement shows an enlarged version of the triangle with 2 sides that are each 3 feet long. What is the length of the third side of the triangle in the advertisement? So here we're going to set it up. So I have my 4.5 feet or inches in the t-shirt design is the same as 3 feet. And now the nice thing about this is I can actually leave it as 3 feet. I don't have to change it. And this has to be same as the 6 inches. We don't know how long that is in feet. So if you cross multiply and divide, you have 3 times 6, which is 18, divided by 4.5, which gives us 4. Alright, one last problem that is your turn. I want you to just pause the video and try this one on your own. So once again, we're using proportions. So here, the sides are each 4 inches long, which is comparing to the 18 feet. So I have 18 feet to 4 inches is the same as 24 feet to x inches. So you do 4 times 24, divide that by 18. So 4 times 24 is 96. 96 divided by 18, it's going to give us 5.3 inches.